let's look at finding some trig ratios, and we're going to start with all of the quadrantal angles. Okay, so quadrantal just means the ones on the unit circle that are on the x or y axes. So that's going to be 0, 90 degrees, 180, 270, 360, and any of those that are coterminal with any of those angles. Okay, so now the nice thing is if you're looking at this sine of 270, and if I know the graph of sine of x, I just look here and I go, okay, well 270 is the same as 3 pi over 2. So that means sine of 270 is just going to be negative 1. If I was also looking on the unit circle, I would know that that is the coordinate point 0, comma, negative 1. And the y value corresponds to sine. So that's our answer for this first one. Cosine of 90, well, again, I can just look at the graph of cosine of x, and I can see that it's going to hit 0 at 90 degrees. So I can put 0, or I can think about that the x value on the unit circle is 0, comma 1. Okay, moving forward. So if we have 540, right, we just need the coterminal angle. So 540 minus 360 is going to give us 180. So if I know that this is the same as cosine of 180, well, I can go again, look at my graph, and I see it's negative 1. Or I can look on the unit circle and see that it's the coordinate point, negative 1, comma 0, and cosine corresponds to the x value. Negative 5 pi, well, we just need to add 2 pi until we're back between 0 and 2 pi. Well, one shortcut here is that I could just add a multiple of 2 pi. So 3 times 2 would be 6 pi, right? So why don't I just add 6 pi? So I know that sine of pi, or sine of 180, is the same as sine of negative 5 pi. So if I look at that, I go to my graph of sine, and I know that sine is going to be at 0 when we're at 180, which is coterminal with negative 5 pi. Okay, moving along. So tangent has to be sine over cosine, right? So you just need to look at both sine and cosine. And so if I think about, okay, well, sine of 180, going back to my graphs over here, well, I see that sine of 180 is 0, and cosine of 180 is negative 1. Okay, remember, I can also always go to that coordinate point, and that coordinate point would be 0, comma, negative 1. So that would help me solve this. Now, so this is just equal to 0, right? Let's look at one last one, cosecant of 1080. Well, 1080, well, if you go ahead and you start subtracting 360, you're going to quickly find yourself at 360 or at 0. Let's just subtract 720, and that's going to put us at 360. So that means that cosecant of 360 is equal to cosecant of 1080 or 1080. So cosecant, right, means it's just going to be 1 over sine of, and I now know that it's the same as 360, right? And we got a problem, right? Because at 360, we're at 0. So that means it's 1 over 0, but that can't work. We can't have a 0 in the denominator, so this last answer here would be does not exist. Okay, let's look at some actual angles that would force us to use these two special triangles. Okay, so we know we got two special triangles here. We got 30, 60, 90, and we have 45, 45, 90. So let's try this first problem here. We're going to start with sine of 225. So the best thing you can do here is first find where your terminal side of the angle lies, and that's going to be right over here. So we thinking about our unit circle, we got 90, 180, and 225. And then we're thinking about our reference angle, right? We got that reference angle that is between the terminal side, or the hypotenuse, once I draw a triangle, and the x-axis. So the reference angle is 45 degrees. So what I'm going to do here is use these sides that I know, but I'm going to think about the direction. Because we're going in the negative direction, we're going to go over negative 1 and down negative 1. and the hypotenuse is always going to be positive, which gives me square root of 2. So now I think about the sine of 225. I think about that using my reference angle now, and I think opposite over hypotenuse. So opposite over hypotenuse gives me -1 square root of 2. And just remember, if you wanted to rationalize the denominator, that would give you negative square root of 2 over 2. Okay, so either answer is suitable here, but more commonly you'll see the number written with the denominator rationalized. Okay, moving along here, let's do the next one, tangent of 300. So I'm going to do the same thing. I'm going to go around my unit circle. Obviously, I have to go past 270 here, and this is 360 or 0. And so once I go all the way over here, I see that I have, here's my terminal side. I think about, well, what's my reference angle now? Reference angle here is going to be 60 degrees. So that means when I draw my triangle, I'm going to have a triangle that goes 1 in the positive direction. So that's this side right here. And then it's going to go square root of 3, but in the negative direction. So I'm going to put negative square root of 3, and then that's a 2. Keeping in mind that we're corresponding with our 30, 60, 90 triangle. So now I go to tangent. Well, tangent is opposite the reference angle over adjacent. So negative square root of 3, let's redraw that. Negative square root of 3 over 1, well, that's just the same as negative square root of 3. So we have our answer here. Okay, let's do 2 more here. And these are going to get a little more tricky, but just one extra step here. So look, here we have secant of negative 210 degrees. Well, if we have negative angles, just add 360. And once you're back at that positive angle, you know that 150 is coterminal with negative 210. So I'm just going to use 150 because I know that that's going to give me the same answer. And 150 is going to put me over here. I know my reference angle now. I know my reference angle is going to be 30 degrees because I have 180 to get to right here. So 180 minus 30 gives me 150. And now I'm going to draw my triangle. I know opposite the 30 degrees is going to be 1. It's going up, so it's going to be positive. And this is going in the negative x direction, so I'm going to put negative square root of 3. And as always, my hypotenuse is positive, and that's going to be 2 in this special case of the triangle. So now I use secant, right? Remember, secant, we got to remember, is going to be hypotenuse over adjacent. So that's going to leave me with 2 over negative square root of 3. Or if you rationalize the denominator, you would more commonly see this written as negative 2 square root of 3 over 3. Either answer is correct here. Okay, last one, tangent of 780. Well, first of all, if we're going to figure out where 780 lies, we need the coterminal angle. So 780 minus, well, I could go minus 360, but I'm going to have to do it again. But I know that 720 is 2 times 360. So that's going to leave me with 60 degrees. So really, tangent of 60 degrees is going to also give me tangent of 780. Get the same answer, right? So I know that this is the easiest one. When we're in the first quadrant, right, our reference angle is the same as our angle, which is 60 degrees. So this is going to be, everything will be positive now. That's going to be square root of 3. Down here is going to be 1, and this is 2. So remember, opposite over adjacent would give you positive square root of 3. And now we're done with this one.